Greetings everyone. My name is Saad Mahmud. I'm a final year student studying in Curtin University, Malaysia. And today I'm going to be discussing about my final year project. The topic for my final year project is meta learning in BERT natural language processing application. Natural language processing, or NLP for short, is a field in artificial intelligence concerned with human linguistics. Did you know you use this field, natural language processing or NLP, in your day-to-day lives for most of your day-to-day activities? For example, when you search in Google to show you a map of a city, or you ask your speech assistants like OK Google, Alexa, or Siri to set a reminder, or to send an email, or to keep a note of something, you're interacting with the field of NLP. So one of the most popular models used in this field is called BERT. BERT was originally invented by Google, and this model can be used for a multitude of tasks such as question answering, sentiment analysis, language translation, etc. In our FYP, we try to train this model in such a way so that we get better accuracy or better performance than existing literature or existing methods. So on the top left, we can see a picture of the BERT model. A BERT model essentially is a very simple model where it just it takes in your input sentence, and it tries to create an embedding for each and every word of those sentence. An embedding is a mathematical representation which is supposed to capture the meaning of the word. So we propose our own training method for this model, and we try to optimize the model so that we get a better result. On the bottom left, we see our proposed training method. So we train the method using two loops. In normal training, you use one loop where you pass in the input to the model and you get your output, and from there you get your loss, and from there you optimize the model, and then you send your input again. In our method, we train using two loops. The inner loop is used to optimize the model for better accuracy or better loss, or lower loss. In the outer loop, we try to optimize the model to learn better model parameters. So what this does is it creates a model that can generalize to a multitude of real life tasks, and it leads to a better real life accuracy. So on the bottom right, we compared the results of normal training with our proposed training. Uh, we use the smallest BERT model called BERT Tiny, and we tested on the MNLI dataset. The MNLI dataset is one of the datasets that is used to train models train models in the field of NLP. MNLI dataset has two parts called MNLI matched and MNLI mismatched, when we try to compare our results for both these sections. So what we see is using normal training on the BERT Tiny model, we see that we receive an accuracy of 46.72 and accuracy of 47.64%, and we receive a loss of 1.03 1.025 for the loss for the MNLI matched and MNLI mismatched sections. And using a proposed method, we can already see a 10% accuracy boost for both MNLI match and MNLI mismatch. We see our score is 56.82% and 58.61% for MNLI match and mismatch respectively, and we can see we achieve lower losses as well. Just a side note, this project has been selected to compete in the 2020 APEC HPC AI competition. This competition is mainly sponsored by NVIDIA, and the purpose of this competition is to achieve better scores than using existing literature. That's all from me. Thank you.